Hey everybody, welcome to this webinar about Twin Studio, which is our new software offering. And it's basically a way to automate the preparation of CAD assets for visualization and getting them ready for rendering. And if you do any kind of work with product rendering, you know that it's pretty difficult to take a CAD model and make it look beautiful. There's a lot of steps of processing and data manipulation and 3D file fixing that need to be done. And we're going to talk about how this software basically is our solution to help improve that whole process so you can come up with a really nice model. So let's see. A bit about me, senior 3D technical artist here at DGG. I've been here a couple of years. Before that, I was 6 years at Wayfair leading the 3D team there and making digital twins for both rendering in V-Ray and also for real time for product configuration and web spinners and AR viewing, that kind of thing too. And then before that, it was about 20 years in game development as a 3D artist and art director and technical artist. And I'm also a member of the Kronos group through DGG and through Wayfair, contributing to the development of glTF as a format. So I'm in weekly conference calls with industry leaders across the spectrum of companies that use 3D for visualization. And we talk about ways to improve glTF and incorporate feedback from the community and help to drive that format forward. So it's been a great opportunity for me to be a part of that whole process. And what's great is that DGG is really focused on supporting open formats. So you'll see as we dive into the software, USD is really well supported, Material X and PBR and glTF, of course, everything else. So we'll talk a little bit about RapidPipeline itself, what it is. It's basically a software suite that lets you handle the processing of 3D files. And it's a set of tools. We have a web platform. We have integrations into your favorite DCCs. And basically, you can take files from just about any format and convert them into 3D assets that perform really well for a variety of tasks. And in particular, we've been focusing lately on CAD formats and how to really focus in on improving the way to process those files. We'll talk through some of those issues as we go forward. So a bit about kind of RapidPipeline on the back end. Basically, our core software is this RapidPipeline engine that runs behind the scenes of all of our integrations. So we have an integration for 3ds Max, for Maya, for Blender, Unreal Engine, Substance Painter, and then the newest is our Twin Studio, which is a separate application that incorporates the engine directly within it. But each one, we have to talk with the back end using a format that works best for the front end. So in 3ds Max, FBX is really the best way to get rich data out that supports the full material tree and animation and all the other things that are necessary. But in some of the other tools, glTF, for example, Blender has a really good glTF implementation for import and export. And so that works really well as a pretty rich format to put things out, and the same with Unreal and Substance. But with Twin Studio, now we're focusing on USD, which is the next big kind of step forward in terms of interoperability format. It's really a great, rich format for handling really rich geometry data, variants, materials, all kinds of great things in there. So that's how our system works on the back end, is that we have this core engine that supplies all these really advanced functions and does a lot of geometry processing. And we talk to different apps as needed. And we're looking at other software as well to integrate with. You should expect to see more updates as we go forward. So today we'll talk about how to get CAD files into Twin Studio and how to process those files and things that you typically have to deal with CAD assets to make them render ready. And we'll try to get through all these things. The most important thing, I think, is your questions. As you come up with ideas of things that you want to hear more about, pop them into the Q&A section and let us know what's interesting to you, and we'll try to cover them. I think we have a couple of people here on the team that are helping out. We should be able to get some answers from them as well. I'll try to do some live demos as well. So let's see, what's next? Let's just launch the application. How about that? Let's get out of this guy. And the application is right now just Windows support for now. It's an we're in beta, right? This is like an early release of the software. It's not, I should say, it's not a production release. We want to get your feedback. We wanted to get it in front of you as soon as possible. You can sign up and do a free trial for 14 days, which is pretty liberal. It's 2 weeks of time to do unlimited processing of your local files. And we want to hear your feedback. Try it out. Go to rapidpipeline.com and check it out. It's already pretty full featured. It's running Hydra in the backend and USD is the core format. So right now, I'm just going to go ahead and import a 3D file. And right away, you can see there's a ton of formats that we support out of the box. So a lot of these are CAD formats. There's like over 70 different CAD formats that are in here. We can also take in glTF files and even VRM, which is for chat 3D stuff, UST and everything. So you can pull in any kind of file format basically that you want, which is great. So I'm going to go to let's see, find my demo files. And I'm going to pull in the drill file, which is about 78 megs. It's a CAD file from Rhino, I think. And it has a lot of features that are cool to demo with. So right away, when you import things, you have an import CAD format options, and you have file format options for other 3D files. And it's primarily USD focused, but other things are in here that can be done with files when you pull them in. But in particular for CAD files, when you are working with CAD data, it's basically a parametric surface, right? It's a 3D model, but it's not made of triangles. And you need triangles in order to do UVs and to do material processing and all those kinds of things. You need a triangulated surface. And especially if you're going out to real time on the back end, which we have a whole integrated system for converting your render models to render ready, but also to real time. So you need to tessellate it first. And we offer some options right out of the box about how much detail to add to the model. So if we go back to the slide deck, I can show that. Let's present that big. Yeah, so basically we have 5 standard options that are kind of presets for how detailed to bring in and turn that parametric surface into triangulated data. And also a new feature for us is also quad-based data, so that it doesn't have to be triangulated. But anyway, you have by default, it's a fine level resolution, and that's pretty good for most cases. You can go more detail if you want, or you can go less. We generally advise pull in more detail at the start and use our decimator to get down to an extra coarse kind of level. And then that way you can choose, the software does nice optimization and doesn't give you these clunky kind of surfaces that you get at this level. If you just need a kind of a proxy representation of your CAD asset, that might be a good solution to use. The other thing we have is custom tessellation. So you can go in and affect these green parameters to finally tune in an even really high res version if you wanted to, beyond what extra fine offers. Because the CAD surfaces are parametric here in blue, and you've got to get out to the red surface, which is tessellated for all your material work. You can choose how fine detail that is. So if you're not getting something great from the default options, you can go in and fine tune all that stuff, which is great. So those are the kind of the options. We have some other things like removing T-junctions, which is where gaps sometimes appear between patches. Converting Z to Y up is something that's pretty cool. Different applications use different kind of conventions for which way up is in their applications. Typically CAD uses a Z up orientation because they're working with elevation data, for example, geospaced data where it's a plan view and you want the up axis to be depth and X and Y for kind of a grid on a flat plane makes sense. Whereas for Maya, for example, works with a screen space analogy where it's, or at least that's the way I look at it, that it's basically based on the proscenium of a theater or a movie. And that's your X and Y coordinates. And then depth is Z into the screen. So that's why a 3ds Max, for example, is Z up, because it started out as a CAD visualization tool, whereas Maya Y up started out as a kind of a film effects tool. So that's what that is. And actually, if we just import it with the default options, I'll show you what's going on. So here it's pulling in this 3DM file it's made from Rhino, tessellating the mesh, and showing us it's got 323 mesh nodes here. And we've got the full scene hierarchy here, so you can look and see what's in the file, what's named and what's not. We can see it's lying on the floor. So that's the Z up to Y up problem, where this was generated in an application that used Z as the up axis, so which is typical in Rhino and other CAD applications. That's how they work. But for rendering, usually you're dealing with Y up, and that's how our system is set up in this app. So let's try re-importing that. And we can set the Z up to do it on import so that it is facing the right way. So if you know you're coming from CAD, you probably want to have this on. And let's just go ahead and re-import that. It only takes about, I don't know, maybe 20 seconds for this app, for this file. This is about 70 megabytes, I think, right? So it pulls it in. Now it's facing the right direction. And we can look at different views here and see what the wireframe looks like and see the tessellation. As I said, quad conversion, that's coming soon. We're working on that process right now, and it's pretty solid. I can show some screenshots of where that's at. And we have a UV view. So this doesn't have UVs on it. That's why it's a single color, but we can easily assign UVs here in the application. And another thing we have is face orientation. So if things are inside out, they'll show up red here. And we can talk through some of that too. We have an automated tool that kind of fixes inside out meshes. So that's the model tab, and we have some things here for recomputing the mesh normals, simplifying the hierarchy and collapsing things. But let's dive directly into the material assignment, because I think that's cool for a lot of people. It's bright here, so I'm going to turn down the exposure a little bit. We can rotate the angle and see how the IBL works. It should all be pretty self-explanatory in terms of how IBLs work and lighting. But the coolest thing here is that you can basically just drag and drop materials directly onto the model, and it auto highlights where it's going to drag. So if I wanted the handle to be black, for example, I could do that, and I could do it per mesh and go in here and just assign it per mesh. But I can also look at the scene materials here and see which materials are actually in the scene and how many assets they're assigned to, how many nodes have this material. For example, this green material here is that one. If I want to assign black to all of the green material, I just drag it directly over the material ball and it auto assigns it. So I'm just going to assign black to all these blue ones. And so that's, instead of doing it at a per node basis, you could do it across the whole model. So for example, this, maybe I want to make that a yellow material or an orange material. So again, I can do it over a single object or over the whole object. And let's try, say, a chrome material for the blue parts. And then I think this text, pink's probably not the right color there, maybe white. So it auto assigns it. And now we've got white text there, but maybe the button also uses the white material. Maybe I want that to be red instead. So then I can just go ahead and override that global assignment. And now I can see one node has this red material. So it's really easy to assign materials. And then the other thing that's cool here is that I can edit materials individually. So if I don't really like this color, I can go ahead and change this and get it to exactly the values that I really want for this surface. So that's color and opacity, specular roughness, so how shiny it is. So if I like a shinier material, that's possible too. And I can see how it works in the view. We don't really have rendering, kind of production rendering set up here, but we want to, that's another feature that we're working on, to render previews that have full lighting and a path tracer, basically, to get you something that's a little bit more realistic. But basically, this software is really meant to be a way to adjust CAD assets and get them render ready. And then because we support open formats, you can go out to any format you want and integrate this directly into the renderer of choice. So for example, I love V-Ray, right? I just love all the flexibility and the visual quality I get with V-Ray. So I can easily export this out and get this into 3ds Max or Maya or wherever I want to render it. But you can use Corona, you could use whatever renderer you like. If you like Blender and Eevee, or you like Unreal or Unity, any of those applications, they work really well with open formats. So it's really easy to get this kind of data out. Another cool thing that we've got here is we've got the ability to take labels that you've got in as bitmaps and basically drag them directly onto the model. And now I can just move it around, rotate it, and adjust it and get it set up to be the right thing in the right spot. So for example, let's go ahead and import a new one, and you can see how that works. So I've got these set up in here, and I've got some logo models, and I think these are different languages. I guess it's not really a variant for this particular thing. Oh, these are variants for different shapes of the model. So I could pull over a different, if I have the turbo version, I can import this label. And now this label is here for me to use. And I can just drag it onto the model and move it around and adjust how it's aligned with the model. And you can rotate it directly on the model and see how it works. And it basically, as you drag it around, let's get it straight again. As you drag it around, it looks at the local orientation of the surface. So it's smart about aligning itself to the surface as best it can, which is pretty cool. The other thing that we need to add is a scale option to scale these when you pull them in, because right now I think we just have rotation. But we will have scale, and in addition to position of dragging it and rotating it here with the gizmo, you'll be able to scale it so it fits. But also, you can set that in the naming of the label. So a common strategy that happens in industries that we've seen is that people use a naming convention in their labels to say, hey, this is 24 millimeters wide, and that's how it should be in real world space and on the model. And so that way it retains that scale of how it is in the real life with the real label. So that's possible as well, a way to automate the scale when you pull these things in. So that's a couple labels. Those have transparency, which is cool. We can also put, I think there's a label that should be down here, which is this information label. Yeah, and this has got alpha so that it shows the material color underneath it. We can say, rotate this to the line and move it around. And so it's all editable and easy to adjust how these things are. The other cool thing I should talk about is automation. So we have this kind of history log here of every action that happens in the file. And so going back in time here, excuse me, you can see all of the various options, things that I've actually done to the surface. The other thing that we have, and it's in early stages here, and that is the history log, which is basically a set of actions that I can go through and see over time what has happened in this file and adjust things. And it's a way to record the editing that you did to the CAD asset here in the application. And then you can, in the future, reapply these processes to another model. So I did all this kind of material assignment here, and I put labels on and adjusted color values and shininess for this yellow material. But I want to save that and I want to apply it to other versions of this asset. So say I have an asset that is bulkier and has a larger battery, for example, and it's a different CAD file. The idea behind this is that I can replay these actions, these choices, with a different CAD model and automatically redo all this work without having to do it all manually. And so the whole system is set up with that automation in mind, that you can create these kind of actions lists and run through them automatically. So if you've ever played with like action scripting in Photoshop, for example, it's very similar to that. where you set up a list of actions, and now it just automatically runs through those with the next file. So that's a great way to speed up your production workflow. So let's go back to the deck and see where we were. We talked to Z to Y up. We talked about tessellation resolution. Oh yeah, small parts. So that's something you often have to deal with in a CAD model, is that you have all these kind of tiny parts, like screws, for example, that are either hidden inside the model or are sticking on the outside. And those kind of balloon the size of your model. But when you're going out to real time, for example, you probably want to hide those and get rid of them easily. And going through and picking them manually is a huge pain in the butt. I don't want to do that. But we have a nice automated routine for handling that. And that's basically removing small parts. And basically, if you look at those little animated GIF here, it shows how all the little parts are selected and just deleted. So that's a really easy way to remove things. And I think if we hide this part, yeah, so now we can see inside the model, and we can see there are all these little screws in here, and these are all nodes in the hierarchy. And some of them are really tiny, I think. There's some small ones down here. Some of these little things. So removing all those is tedious, right? I don't want to do that by hand. But this can all be automated, removing all those little parts. And so basically what it does is it looks at, in scene units, how small are parts that we should remove. And by default, scene units are in meters. So this value is saying anything that's under a centimeter for the largest dimension of its bounding box. So if we look at a screw, for example, and we look at, say, one of the longer ones, the longest dimension of its bounding box, if that's under a centimeter, then it'll be removed. So let's just try it. Let's just run it and see what happens. So what happens here is that it puts the USD file out to our application, and then it re-imports it when it's done, and it will remove, did it not remove anything? Let's try a little higher value. Run it. And look, it didn't work. So I think that's a beta thing. We probably need to re-import the model. Again, this is why this is not production software, right? This is something that we're actively working on. And we want your feedback about when things don't work as expected. If I just import this, I need to redo the Z up. And it should come in. It's plain. I think we're still good. Yep. Okay, so let's hide this thing and look at the interior, right? So we do have those parts. Let's set this to 1 centimeter. Oops. 0, 1. And hit run. Okay, so there, now it did it. And we should hide this piece. And we can see it removed all those screws automatically. So that's a cool thing, right? To be able to remove small parts automatically. It's a very workflow enhancer, right? So let's hide that bigger piece, and we can see, yeah, it removed all those tiny little parts. The other thing is here that we've got all these interior parts that are manufacturing data about how the engine is, and it's got this cord and all kinds of different little parts in here that we probably don't want when we're rendering the asset. We probably don't want these interior parts. So that's what remove occluded parts does, is it looks at anything that is not visible from the outside. So if I go through my list here and find those pieces that were hidden, there's one. And that's something else we want to add, is the ability to sort by these columns. So it's a little easier to find these. But so these things are covering those interior parts. We don't really need those black things inside of there because they're probably not visible in the initial file. So if we re-import that file and see, when we pull it in, that a lot of those interior black parts you just can't see from the outside. So when we did small feature removal, it also removed some of these little panels in here. We probably didn't want that. But if we choose to remove occluded parts, we can probably get away with a bit more what that is. So you have some options here. There's fast, thorough, or extreme for how many rays to shoot at the object to figure out which rays can see through. So for example, in this CAD asset, there's probably some gaps here that you can see through the meshes to see what's inside. So there we can see there's a gap there, and I can see some of the mesh inside. This controls how many kind of rays are shot from the outside of the model to try to find interior models. And if it can't find it from enough rays, then it'll say, oh, it's cullable. So let's just go ahead and run this. If we hide this piece, just so we can see what's going on. If we cull it at the defaults, let's see what happens. It does compute in the visibility for each mesh, and then pulls the model back in. And it's removed some of the parts, but it hasn't removed all the parts. So some of the parts are still visible. We've got some screws here that were probably visible through gaps in the mesh, and we've got some of these other parts inside. We can undo that to get back, and it should show me the full model again, all the parts. Yep, there it is. So instead of re-importing, you just undo. So let's try what part visibility threshold says is how visible can these, how hidden can these parts be before they are culled? So 10% is really a low threshold value for this. You can set a higher threshold. So say if I say 60%, let's set it to 100% and see what happens. If we run it at 100%, basically it'll cull everything, because that means that nothing is covered by anything else, right? It's 100%. Let's undo that, get back to where we were, and pull in all the assets again. Oh, it didn't work. So let's try re-importing that file again. This is why it's not production software yet. We're working through the undo redo history. I think that's probably the most troublesome thing of any software application, is being able to undo and redo things, because you're doing massive state changes across all your meshes you're seeing. So we'll re-import that thing. And where are we? Did it not pull it in? It's empty. What's going on with my view? Let's just restart the application. It's so quick to restart it and make it run again. But yeah, the threshold value basically sets how much to cull things. So let's re-import that file. All my files, go to my demos, and go to the drill. And I do want Z up. Another feature that we'll be adding soon is the ability to save the project. So you can see here in the file menu, we've got open project, save project, which right now don't do anything, but basically it'll save the current state of your model along with any material edits and everything else as a project, so that you can load and resave, get back to the state that you were before. So again, this has all those interior parts. We can go into remove occluded parts, and if we change this threshold value to be something reasonable, like 50%, things can be 50% hidden and still be culled. It's basically what that's saying. So now it computes the visibility based on a 50% threshold. And we should see now that all those parts inside are mostly gone. And that seems pretty good. Is there any gaps here? I think that's actually pretty good. We don't see any holes in the model other than this thing, which was a part of the design. But we've removed all those kind of hidden interior parts. And it's all done with basically just a couple button presses, right? It's pretty easy to do that kind of processing. So that's that part. Let's see, what else? We talked about small part culling, occlusion culling, material assignment. We talked a bit about the automation. Oh yeah, decimation and baking and exporting to web ready. That's a cool thing. And that's a core of what's part of RapidPipeline's history, is we've developed this kind of core system that basically does all this 3D processing to get things out to real time. So I'm going to drag these things back in. do my material assignments here, get the black where I wanted it, maybe chrome on the pink parts or the blue parts. And we wanted white on the text. Let's do red for text, why not? So that's here, and maybe the button's white, why not? It's my object, I can make it whatever I want. And let's change maybe the shininess, right? I like it a little shinier. So maybe a little less rough. So now it's ready to export to real-time format. And one thing that you often get with CAD assets is it's got a ton of nodes, right? It's got all those parts inside. I think we did do the occlusion culling, so we removed all those screws. But even after removing the screws and those interior parts, we still have 220 nodes, and that's going to increase the render cost of this asset. It's also got 106,000 triangles. So we can definitely get that down to a lower number and less nodes. One way to do that is with scene graph flattening. You can basically, without doing any decimation, I can basically say, hey, everything that shares the same material, I want to collapse that down into single node. And so what it does then is everything that shares this yellow material, all these yellow parts, would become, and including all these lettering, right? This lettering is individual little meshes in here. These are individual parts. So all of those, by flattening by material, would be flattened into one yellow node. That's something that's really useful. So let's go ahead and do that. Why not? So I'm going to run this. And now we can see right away, that was really fast. It's basically done one node for all the yellow parts, right? We can hide that and see. One node for all the black parts, one node for all the chrome parts, etc. And let's see what else. So that's scene graph flattening. That's one way to do it. Let's undo that and get back to our 220 nodes. And let's try a different way, which is often for PBR rendering, you want additional textures to be generated. So ambient occlusion is a great example. I want to generate ambient occlusion for this thing and have it be a beautiful model. That's part of our optimization pipeline. So we have a whole texture baker that can go through and bake occlusion map for a model. And basically what it'll do is this thing, I think, doesn't have any UVs by default, it has nothing. So what this does is we'll automatically create a texture atlas for the model at the resolution you specify, bake an occlusion map, and apply it to all the materials. And here, again, you can choose how you want to flatten this. Do you want to flatten it by material so that each material now is one node and not 220 nodes, but like 5 or 6? Or you can say full. I want to flatten it down into one material for the whole thing. And thus it's one draw call, super simple, renders super fast, right? And one texture set for the whole model. So that's what full does. Biopacity is cool. If I have materials with transparency, say a car with glass windows, or say a tea kettle that has glass parts in it, typically you want those glass parts to be kept as separate nodes so that when it renders those in a real-time renderer, it sorts them correctly. That's what this does. This will basically collapse all the opaque parts down into one node because they don't need sorting. And then all the transparent parts, which I don't have any of this model, but in all the transparent parts, it'll keep as separate nodes automatically so that then they'll render still correctly in a real-time renderer. So that's what that one does. And then you can say none. I don't want to do any kind of merging of these meshes. I want to keep all 220 separate ones. So it's really up to you how you want to do that. I'm going to do full just because it's fun. And I'm going to, let's do a decimation down to say 50K triangles. And I'm going to bake an occlusion map, and we're going to use a 496 texture. And there's some other options, but I'm just going to go ahead and do it. So now it's going to go through the process of decimating the mesh, collapsing all these down into a single object, creating the UV atlas so that they all have a unified UV, so they all get unique kind of occlusion baking, lighting baking information. And then it bakes this 4K texture down for us so that we have that occlusion map for it. And then we'll be able to export this out to, say, a USDZ or glTF file and see it in a real-time renderer. Okay, so there it's done, and it's got an occlusion map on here. We can see the result already in this viewer, right? Because there is some kind of subtle shading going on here. And we can see in the UV view that it's created the UV Atlas layout, right? Wireframe is down to less than 50K, so that's pretty nice. And it still retained a lot of the original quality of the model. I don't really see anything degraded like crazy. It's still pretty amazing at 50K. So let's go ahead and export this out. So I'm going to export scene. And I'm going to choose, we've got some options here, glTF, GLB, VRM, etc. We've got some questions already, so I'll go ahead and look at those in a moment. But you've got a bunch of different files you can go out to. I'm going to go to a self-contained GLB file in my folder. Just going to leave it as that name. And it's going to go ahead and do a default kind of export with JPEG textures. We do have a kind of a whole process for exporting files. It's just not in this particular application, but you're able to choose which texture files you want to use. And do you want to use geometry compression, to use Draco and other kind of algorithms to compress the file even further? So there's a bunch of options you can choose on export. It's just not in this demo application yet. But let's go out to my desktop and find that demo assets folder. Okay, and here's our file that we made. So we went from 78 megabytes down to 7 megabytes. That's pretty awesome. So let's pull up a web browser. And where's my web browser? There we are. So let's pull up a 3D viewer. This is the glTF sample viewer. It's a default one for looking at GLB files. Let's find our folder and drag and drop this in, and we can look at the model. So there it is. Now it's a real-time exported 3D file with our material assignments that we made and with an ambient occlusion bake. So we can look through the advanced views here and the debug channels. You can look at the actual occlusion that's baked. And you can see it's nice. It's a very noise-free ambient occlusion texture. There's one mesh here, less than 50K triangles, one material, really very efficient. The other thing we can do too is look at something like glTF Report is a really cool tool that's built on Three.js by Don McCurdy. And it's a really cool tool for examining mesh data in glTF format. So when you drag a glTF file in here, it has a nice render view, but you can actually look at the textures too and see how the textures are made. So it's got a base color texture. It's got a normal map, which is cool. It's actually baked normal map data from the high-res source onto the low-res decimated file. So we can actually look at it here. The normal texture is there. And this has actually added some shading detail where it lost some resolution by going down to 50K triangles from 220 or so. So that's helpful in terms of if you want. You can also just disable that and say, hey, I don't want a normal map. You can remove that as well and just say, I don't want to bake that. So if we look back at the application, we have a bake materials option here. And this says basically, if I have normal maps in the input file, I can always bake those out. And if they're in, I can always bake them out regardless of whether they're in the input file or not, or only bake normal maps if they're in the input data. So if I have a tiled normal map across one of these, it'll then bake that for that material, but not anything else. And then you can say also, hey, I don't want to bake any normal maps. Even though I'm decimating down to a lower res, I don't really care. Just show me the shading that I get from that and don't bake a normal map. So that's that option. And we looked at it here. What else? You look at how things are set up in the file and whether there are any errors, validation, and all that kind of stuff. So that's the process of getting a CAD-ready digital file out and ready for rendering. If we look at the deck again, that's that. Let's go to Q&A. Oh, another thing I wanted to talk about too is fixed winding order. So that's kind of an important thing to get to in CAD files is often CAD data will come in with some of the surfaces flipped inside out. So this car asset, I think it's a 400 megabyte CAD file. And so it takes a while to import. It's like a minute and a half, something like that. But some of the surfaces are flipped inside out. And usually that's not a problem for renderers. They'll just render every mesh is double-sided and you won't be able to even tell that it's a problem. But in some renderers, that's not going to be great. For example, this is a render of that asset with these flipped surfaces, just rendered double-sided, but rendered in Substance Painter. And in Substance Painter, it's been assigned a material with a metallic flake kind of car paint material. And that particular material uses, I think, anisotropy rendering to do that and normal mapping to do that kind of effect. And for those kinds of rendering effects, you need surfaces that are facing the correct direction because those things rely on tangent space data in the mesh. And if it's flipped inside out and you're just rendering the backside, it's not going to give you that kind of smooth curvature. So you end up with these seams and problems. And our fixed winding order tool automatically fixes that and just flips all these things. The other thing that you see too with these flip surfaces is if you bake an occlusion map, that's what's done here, without fixing those flip surfaces, then you get these problems where the occlusion map is inside out. And thus these surfaces are facing in instead of out, and they get occlusion to look super dark. And so it's really messed up. But we talked about removed occluded parts. But that the fixed winding order tool fixes that automatically. And it's pretty cool. It works really fast and it's easy. So let's take a look at your Q&A and see. I think we have 4 questions here. The first question I see there is, how do I get smooth meshes when the CAD is really chunky? Yeah, so that depends upon if your CAD file says it's really dependent upon the resolution that you tessellate at. If you choose extra coarse, it's going to be clunky. But the CAD data itself, usually it's a parametric surface. So for example, it's going to be basically infinite curvature based on how it was generated. And the tessellation is what turns it into a chunky surface. But if your CAD file, just doesn't have any detail, it's just made of boxes, for example, there's really not much you can do in terms of basically improving that curvature. The source data is messed up. And sometimes CAD data is stored actually as triangulated data too. So you watch out for that. We do have a remesher, which is pretty cool, which basically, I can show a web viewer version of that. We have in our tutorials, we have one for, let's see, where is that? We have one about remeshing that's pretty cool. I think it's in here. Yeah, remeshing. So for example, this guy is a file with wicker, and the wicker is all modeled, right? There's a ton of geometry here that's created for this asset. And what we have is a remesher that basically will shrink wrap that with a new mesh and then bake all those whole data into an opacity texture or an alpha texture. And so that's a great way to take a really complex surface and kind of preserve all that detail as a texture. So that's something that could be done if your CAD asset is super chunky. You could average across the surface and make a new thing with the remesher. Junk data in, junk data out. I don't think you're going to really be able to solve a clunky looking CAD model. That means making new mesh with that model. So that's that question. Let's see what else. We got another one that's purchased models from various online stores often have messed up texture mapping with broken pathways and poorly organized file. Can the cleanup and reconciliation of this be automated? Yeah, so you can support some of that, right? If it's missing textures, there's not that much we can do with that data other than you can, if it is an ASCII-based file, like a USDA file or a glTF file, you can go in and find and replace those broken paths. Basically, we look to try to find the paths that are in the file, and if those are there, we'll load those textures. We also look in the folders of the file to see if the subfolders contain that texture as well and try to load it. But if the textures aren't a part of the original folder structure or the paths aren't set to the right absolute paths, you're screwed, right? You need to pre-process that file to fix those issues. But you can go through and do find replace in a file and find and have those files be handled. There are ways to, if the UVs aren't great, we can generate UVs on the fly. For example, let's pull in another file and talk about UVs a little bit. I'm going to pull in this USDA file. So I have a shader ball here, and I'm just going to import it with the defaults. So here's a shader ball, and this thing has UVs. Let's see, there's UVs on this thing, but if I don't like the UVs, I can regenerate them. So first of all, let's put a material on here that has texture. Let's find one that has texture. Oh, there we go. So there's some texture, but I don't like the way it's been parameterized. For example, this guy has a pole on the back, and I don't really like how that pole is stretching the texture. You can just right click on the model and you can regenerate UVs with a variety of options. So the first one is cube mapping, and basically it'll do a six-sided projection on the model. So let's look at the UV view. It's done 6 different projections here. And there's a few seams here, and maybe it's not the greatest, right, for this particular asset. But I can choose, say, organic atlas, which is better for curved surfaces like this, and that it tries to find the least stretching possible while creating a few seams. So if we look at UV view again, there it's created seams based on the curvature of the surface. And when we look back at the textured view, I'm hard pressed to find those actual seams. It depends obviously on the texture you've assigned to the model, but you can fix models this way. It's a very easy kind of way to handle something. If we have something like, I think this one, oh yeah, this one has a very obvious kind of texture pattern, right? So it's a little easier to see whether your seams are. If you want, you can try like a sphere parameter, for example. So this is spherical UVs. Again, we're back to where we were with the default ones, and that there's a pole at one end, but maybe that's better for your viewing angle and your options. It just depends on the material and what you're trying to do with it and what the textures look like on it. So that's quick and easy kind of UV options, right? You can do cylindrical UVs if you want. There's just a bunch of different options there, which is nice. But there's also, when you do a bake and baking atlases out of this, then it automatically generates the UVs and packs everything together for you. And so that's what we had for the drill asset. So that's that question. Let's see, how are we doing on time? Pull up our status bar here. Go out to the desktop. Oh gosh, we got 7 minutes left. Let's see what else. We've got, how do you optimize when there are lots of fine details like screw holes? Okay, yeah, so screw holes, we've got a typed answer in there. It's pretty cool. Let's do a quick demo of that because that's really cool to see, actually. And this asset is a great example of it. We've got what's in here is, let's show the scene tree. We've got a core asset inside here. We hide that. We can see this thing is basically a hollow sphere with this big opening in it. We can automatically fill round openings like this. It's like a screw hole by going in and either filling surface holes, which looks at single-sided holes and automatically fills them. This is actually a hole with depth. So this is defeature solid holes. This is a brand new feature. And basically it looks at what's the diameter of the hole in the surface and tries to find all holes that fit that diameter or smaller, and will fix those. So by default, this is set to 40 millimeters, which is 4 centimeters, right? 10 millimeters in a centimeter. So 4 centimeters across. I think this thing, the whole thing is about 7 centimeters across. So let's try this to see what happens. and goes ahead and runs it. And oh, look at that. It just filled it in. Now, what it does is it tries to anticipate what the UVs should be for that surface, but it's trying to interpolate new UVs across the filled surface from the edges. That's where it's maybe not the best solution, but we can automatically fix that again by just doing an organic atlas. And now we've got great UVs across that surface again. And what's cool is that it's actually smoothed that surface across. So we look at the geometry, we can see it's basically just filled in that hole. And if we undo and get back to the original surface and see, there it is. Oh, crashed out to desktop. That's a fun one. That happens, but we're working through that. I think our next update has major stability improvements in terms of the undo and redo. So let's see, I think we're at time. Any other questions here that I missed? I think that was it. Last couple things are, the hole filling, right? And then basically filling holes, even if they're off axis, it'll fix those. The quad remeshing, that's something that we're working on. And we've got already in the tool, we've got this way to recompute normals. So area recomputing is basically what you call face weighted normals, where it will force the curvature across the bevels of a surface and create really smooth normals. Whereas angle works better for organic meshes, where you want smooth, rounded curvature across the whole model. But area works great for mechanical models. And so that's a default for us because a lot of our inputs are CAD assets. But if you have organic stuff, you can use angle instead. So let's look again at our time. We got 3 minutes left. Let's see, what else can we do? Oh, we can do let's take a look at the fixed winding order real fast. That's cool. So I'm not going to pull in the car asset because that takes a minute and a half to load. But if we choose something like, oh, this robot arm, and this is 14 megabytes. So when we pull it in, I'm going to do convert Z to Y up because it's a CAD file, but I'm not going to fix the winding order. And we'll see that I think this one has a problem. So we'll see right away. So when it imports, oh, it was on a different axis. So it was Y up. So let's re-import that guy. So all files, it's the robot. file. We're not going to convert Z to Y up. So now it should be facing up. And the file, it looks okay, but when we look at face orientation mode, oh, we can see right away, this thing's inside out. Whatever's red basically is marked as inside out. And if you tried to bake like an occlusion map, that would just turn black. So what we have is an automatic way to fix winding order. So let's re-import it with the fixed winding order in the import, because that's cool too. So robot, open, and this time I'm going to fix winding order on input. And let's go extra fine. What the heck? Why not? And just leave it at that. So now when it imports, it'll do extra fine tessellation. And it's done. And if we look at face orientation, it's all facing the right way. And it just does it automatically, right? And it does it on, not on a per triangle basis, but it does it across whole elements of the model, all the connected vertices. So it'll do it not on a per triangle and kind of mess things up and have some things be inside out and others not. So now if we go in and do, say, a decimation and bake, so here we're going to bake occlusion map and we're going to take it. It's already pretty low res, so I don't need to decimate. Let's just do a bake materials and say, don't bake a normal map, do bake an occlusion map. Let's flatten it down into one object and bake it. Now it's going to go ahead and create UVs, collapse it all down into one object, do the 2K ambient occlusion bake, and there we go. So now we have ambient occlusion, and it's still all facing the right way. It's got UVs. We'll go in and assign a new material here, but that'll change the material that's there. we already have a texture, we probably don't want to do that. We can just change the color. Maybe I want it to be metallic, right? And be super specular. So anyway, that's how the whole process works. And I think we're probably at time by now, right? How are we doing? Yep, we're at time. Look at that. Perfect. All right. So anyway, thanks for coming. I really appreciate your views and thanks for the questions. That was really informative. And we have a recording of this, so we'll be posting it on YouTube in probably about a week or so. And for any of those that missed it, you can check it out. And thanks again for coming. Let's see how we do this. Stop the share. What else? I think that's it. Thanks again for coming on.